Today we will be talking about conservation of momentum. Conservation momentum means that the total momentum of a closed system of objects will be constant. A closed system is defined as a system that isn't acted upon by any outside forces or experiencing any non-conservative forces. In other words, this means that the initial momentum will always be equal to the final momentum of the system. Mathematically, conservation of momentum is expressed as m1v1 plus m2v2 is equal to m1v1 prime plus m2v2 prime. Now, let's look at a demo demonstrating the conservation of momentum. We will drop a tennis ball on top of a basketball and see what happens. The tennis ball went much higher than the basketball because some of the basketball's momentum was transferred to the tennis ball. It is important to note, however, that the momentum was conserved throughout the entire demo. Now, let's look at a problem to use conservation of momentum equation to solve for the initial height of the tennis ball.
Knowing the mass of the balls and the heights they bounced to, we'll calculate how high they fell from. The conservation of momentum law means the sum of the momentum of the two balls after they bounced is equal to the sum of the momentums before they bounced. If you consider both balls, the momentum was not lost nor gained during the demonstration. It was only redistributed between them. Only the force of gravity acted on the balls, so we can use projectile motion and the bounced height to find the speed before and after bouncing. Each ball's speed is determined by the height it bounced to. The racquetball and basketball masses before the bounce can be added together because they had the same velocity before the bounce. The velocities of the balls after bouncing are related to the height they bounced. After a little algebra, we find the balls must have dropped from a height h1 of about 0.6 meters.
What we just saw was that the tennis ball went a lot higher than the basketball, and this is because whenever they dropped, the tennis ball received the momentum from the basketball, which made it bounce a lot higher than it would if it was just dropped on the floor by itself. Because we don't live in a perfect world, we have to consider external factors that affect the final velocities of the ball. The coefficient of restitution E is a number between 0 and 1 that takes into account the material the ball is made out of, the size and shape of the ball, and it also tells us why there are no perfectly elastic collisions in the real world. Direct central impact, like the one we just witnessed, the coefficient of restitution is simply the difference between the final velocities of the ball, which are denoted with a prime, and the initial velocities of the ball. For an oblique central impact, which is just non-direct, it means that at least one of the velocities is not lying on the line of action. The only thing that changes is that you're going to use the initial and final normal velocities instead of the entire magnitudes. The coefficient is usually given in the problem or something you need to solve for.